This video will review the comparison operators and logic operators and help understand why they fit into something called a Boolean expression. First of all, the comparison operators are used to compare two different values. They take two arguments, one on the left and one on the right-hand side, and they're used to help us compare whether or not something is less than, greater than, less than or equal to, greater than or equal to, and not equal to. In all cases, the result of this expression, called a Boolean expression, returns a single Boolean value. So if I were to compare 3 is less than 5, the result of that expression is a Boolean value, true. If I were to compare 3 is greater than 5, the result of that expression is false. We can store these into a Boolean variable. And as we'll see, we can use them in bigger expressions to help us decide with our program what to do next. Logical operators allow us to compare Boolean values so that we can evaluate a new Boolean result from that and put it into a larger expression. Here we have the AND expression, which takes two values, one on each side. The AND expression only returns true if both the left and right-hand side also are true. In this case, I literally put in the values true. However, I could have put the Boolean variables that represented a true or false value into this expression. The OR expression allows us to determine one or the other. And this evaluates to true in the case of any of the arguments in the expression are true. Not allows us to take and flip the value, so if we had not true, that would represent false, or not false would represent true. And the fourth one, this is the least frequently used, however this is called the exclusive OR. This expression only evaluates to true when one argument is true and one argument is false. I like to compare this to a two-light switch that you have in your hallway at your home. When both light switches are up, the light is not on. And when both are down, the light is also not on. It is only when one is up and one is down that the light turns on. Let's see how this could be used in a broader expression. Here, the result of the expression is 3 less than 5 and is 5 less than 10 is only true if both of the variables involved in this expression are true. The result of that is going to be stored in the Boolean variable called bigger bool expression. Let's try using this to now solve one of our exercises. Old 35. Return true if the given non-negative number is a multiple of 3 or 5, but not both. Now, it already has return false in here to make sure that the code compiles, but what we can do is we can get rid of this, and the way that we read this is that our body of this method needs to return a value that is true or false. We take in a single number, n, non-negative, and we're going to check to see if it's a multiple of 3 or 5, but not both. So let's go about solving this. Here what we're saying is n is a multiple of 3 and n is not a multiple of 5. I'm going to put some parentheses around this just to help break it up and show how this goes together. What will happen is this expression here will get evaluated first, then this expression will be evaluated, and then what it will do next is it will evaluate this whole expression together with the and between the two. If this happens to be true, then we can return true. Else, let's check to see if n is a multiple of 5 and not a multiple of 3. The same thing I'm going to do here is put some parentheses around this to help group it. It doesn't really change much in this case of the program, but it does help make it more readable. I'm going to say if this is the case, then I'm also going to return true. Otherwise, in all other conditions, I want to return false. Now the next thing we're going to do is we're going to run this and make sure this works first before we change any more code. I'm going to open up my Test Explorer and I'm going to run all. I'm going to go down here and I'm going to see that old 35 passes. Good. Let's see if we can simplify this anymore. So we see that there's a lot of duplicate code here, and right now we're saying if n is a multiple of 3 and not a multiple of 5, return true. Else if it's a multiple of 5 and not a multiple of 3, return true. We can do a couple different things here. First of all, we really see that this else doesn't add any value because it's not really checking for any conditions. And we can assume if it makes it this far, then it's probably going to be return false. And so I'm going to pull this out first, format my code, and I'm going to run my test again to make sure it still passes. Great. The next thing we can do is we can add an OR expression here. And so we can say, in this case, we can reduce the duplicate piece of code here, and we can say if it's a multiple of 3 or multiple of 5, but not the other. The way we have to do that is we will add some additional sets of parentheses. Then we're going to say, if it is the case, return true. It's hard to read all in one line, so what I'm going to do here is I'm going to break it up to a separate line. And now the way I can read this at least is I can see that this goes together, or this goes together. Let's go ahead and check again and see if it still passes. We're still good to go. The other way we can simplify this is to use an exclusive OR. The way that works again is that one or the other, but not both. And the way this one looks like is it says it's either divisible by 3 or divisible by 5, but not both. The way that we can simplify that is we can change this to be evenly divisible, get rid of this expression down here, and change the AND to an exclusive OR. Let's run this test again to make sure this still works. We still pass. The last thing that we can do here to make this shorter and easier to read is if we look at this, this is a Boolean expression. The result of this is a Boolean value. And right now, the way we're saying this, we're saying if true, return true. We could simplify this instead and do return n mod 3 equals 0, exclusive OR n mod 5 equals 0. And the idea here is that if we use this, then what it will do is it will say, if the result of this expression is true, it will return that value true. If the result is false, it will return that value false. Before I get rid of the code that I commented out, I'm going to just run this again to make sure it passes. It still passes, and so now that it does, I can remove the commented out code. So here you've seen an example of us taking and finding a working solution using if, else if, and else logic, and doing something called refactoring down to a simpler, shorter solution that still uses Boolean expressions.